Have you ever wondered how the climate is changing? It's not just a hunch or a feeling, there's math behind every headline, every forecast, every warning. So, let me take you through the numbers that shape our future. Let's start with the basics. Climate isn't just the weather outside your window. Mathematically, it's the pattern of weather averaged over 30 years. Think of it like a deck of cards numbered 1 to 20, where each draw is a day's temperature. If I start slipping in higher cards, say 21, 22, the average goes up. You'll still see chilly days, but heat waves show up more often. The proof? We're now seeing more record highs than record lows, the ratio flipping as the climate's deck reshuffles. But how do scientists this shift? Enter regression analysis. Picture a graph of global temperatures since 1850. The slope used to crawl upwards, 0.0044 degrees Celsius a year. But in recent decades, that slope quadrupled. The math is clear. The planet's heating up and it's speeding up. And it's not just thermometer readings. We track glaciers shrinking, seas rising, species on the move, all mapped and measured with statistics. Now, about predicting the future. Climate models are like recipes that blend physics and math. The simplest energy balance models use equations to juggle how much sunlight Earth absorbs, how much it reflects, and how much heat it loses. More advanced models, called Earth system models, tie together the chaos of the atmosphere, oceans, and ecosystems, all using hefty mathematics like partial differential equations. But here's the catch. The world is messy. Tiny things like clouds or ocean currents can't be perfectly modeled, so we use clever shortcuts called parameterization. Sometimes, randomness itself is the rule. That's where stochastic models come in, using equations that add a dash of unpredictability, just like real weather. In our high-tech age, machine learning joins the party. AI tools can spot short-term patterns, like sudden spikes in CO2, faster than any human. But they stumble when asked to predict far-off futures. That's why we blend them with physics, always double-checking the math. It's not just about temperature. Mathematics lets me map how warming scrambles the calendar for plants and animals, or how ocean acidification eats away at plankton. Delay a predator's meal by just a bit and entire food webs can collapse. Of course, there's always uncertainty. Some comes from not knowing how much we'll pollute, some from the limits of our models, and some from nature's own chaos. Sensitivity analysis helps me spot which unknowns matter most. Looking ahead, we're building sharper models, so detailed they capture every thunderstorm, but needing supercomputers the size of football fields. And with digital twins, we're starting to simulate Earth in real time, testing what-if scenarios before they play out. So, what's the takeaway? Math turns climate change from a vague threat into something we can actually understand, predict, and tackle. The numbers warn us. To stay under 2 degrees Celsius of warming, emissions must peak before 2030. As our models grow smarter, they become the compass guiding us through uncertainty. Math isn't magic, it's everywhere.